Welcome! Today we're going to look at 7 segment displays, and they come in multiple formats with multiple digits. We have one with 3 digits, we have one with 4 digits, we have a old Soviet one. Works the same, it's a bit different, requires different voltage, different setup, works the same, sorta. So, the problem with these is a lot of people buy them with good intentions. They are building some sort of device and they want to represent some numbers here, some values. But then they get to the pins and then they get stuck and then they drop the project or try to replace it with something else. So, today I got this. I got no documentation on this. I have no idea what the pins are, and I have no idea if it's a anode or cathode device. Today I'm going to debug this thing, and then I'm going to connect it to a Arduino, and I'm going to represent some numbers, and we're going to do it stepwise. So we're going to first identify the pins, then we're going to connect the pins correctly to the Arduino, and then we're going to use a library already available from the internet to represent some numbers. So the amount of coding or electronics we need to know to make this work is very limited. What you need to think this is basically just a bunch of LEDs, and we're just going to turn them on and off separately with the help of the Arduino. The problem with these is when you buy these from China or eBay or wherever you get them, they are not, well, they can be, but in general they are not using a standard. There is a standard on how these pins should be, but very often they are different. So what you might expect would turn one thing on does something completely different. And it doesn't say anywhere if it's a anode or cathode either. You could test it with a multimeter if it was a single digit display, but this is a 4 digit. The other problem with using a multimeter is inside a multimeter there usually is a 9-volt battery. A 9-volt battery will, in this case, if you're really unlucky, burn out the LED, effectively breaking it as you test it. So we're going to test it using the 5 volts from the Arduino through a resistor, very important, and then identifying the pins. When we have identified the pins, we're going to program some code. And we're not really going to program some code because the library we're going to use already has the code we're going to need to use this device. So, without further ado, let's get into debugging or finding out the pinout on this device without any documentation. Okay, testing time. Get some light on, there we go. So, first of all, we have the old Soviet type of segment displays. These are very special. They require much more voltage than the modern ones. However, they are extremely cool. This one in particular is multicolored. It's orange, blue, and you can light up the background as green. But it has a lot more wires on both sides. You can see it has 7 down here and somewhat more up here. You can identify the pins using a low voltage, and low voltage when talking about these are usually 12 volts. So if I were to identify these pins, I would use something like 10 volts. On the other hand, if you take a piece of paper behind it, you can easily trace each pin down to where it's connected and see where everything is hooked up. So you don't really have to use electricity to identify which pins does what. But you can sketch it out on a piece of paper like this and draw out what does what, and then name them. Very, very cool device. Then we have our normal 3-digit segments, and of course our 4-digit. Immediately there are no differences except the number of digits. However, on the back this one has 11 pins and this one has 12. So considering that, then we must believe that the last extra pin on this one is to enable the last digit, because this one only has 3. So I would guess that a 2-digit segment would have 10 pins. Off we go, let's work with this. It's big, it's very easy to see what we're going to do. So I don't know what type of segment this is, if it's a anode or cathode. I don't know which way the voltage is going to flow, or the current, sorry. But I do know I need to current protect, so I got some resistors prepared, and I got a lot of wires. So let's identify the pins and what they do. So first of all, I'm going to place it on the middle, approximately on the middle of my breadboard, and I got a piece of paper ready, got a pen, and wires, and of course 3 resistors. So first thing I do is power on my Arduino, because I'm using the 5 volts to identify the pins on this circuit. So first of all, red to the power bar on the top, into 5 volts down here, black to ground on the Arduino, and on the ground bar on the lower part, right? Next, we are actually going to simply test them by putting current in between 2 ports, one at a time. But before we do that, we need to identify each segment of these, so we know what to call them. And to do that, I looked it up on Wikipedia. Thank goodness, Wikipedia. There we go. And this represents one single digit. So we can see top one A, B, C, D, E, F, G. Meaning whenever one of these lights up, it represents one of these letters. The DP is the punctuation. So I'm just going to type that over on a piece of paper. So going to draw this thing. You can see I got my 7 segments. So I got A, B, C, D, E, F, G, and DP for the punctuation. There we go. And now it's a simple matter of testing my way out of this. So the way you name the pins is when you have the punctuation downwards, the bottom left pin is pin number 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First pin I want to test is 12 and 11. So the way I do this is I take a resistor, I put it on the power and into a empty pin, so into an empty row, so I got a resistor right there. Then I'm going to take a wire on the minus bar and a wire on this new resistor, so we got effectively something less than 5 volts here, and I'm going to hook that up to pin 12. Let's flip that over, and I can see pin 12 is that one right there. So there we go. Now it's hooked up, and now I can just put this into any one of these and see what happens. Amazingly, we were lucky. We have chosen the correct current path. digit number 1 has lit up the number D. As you can see, D is the bottom one. So we have D1 on right now. If I, for some reason, had done this in reverse, so this one was up here and I was sending current the other way, none of them would work. As you can see, I can try multiple, none of them is powering on. If none of them is turning on, then you are in reverse of the current, because LEDs work just like diodes. You can only run current through in one direction. So I believe it was that one. There we go. Now we got the punctuation. So what does this tell us? Well, it tells us that port number 12, the last one up here, is digit 1. So let's just type that in on MartinCAD. Port 12 equals digit 1. Another thing we need to type in right away is I'm going to make a row, something like that, and then I'm going to identify the pins down here. So this one is right now in port number 1. So port number 1, this one lights up. This one is called E. So 1 equals E. I put it in number 2. It's the bottom one. 2 equals D. 3 equals punctuation. That's DP. 4 equals the line. So that's C. 5. Come on. 5 is the middle one, so that's G. 6 is not working, so let's put that up here. And then we move to the other side because we only have 6 on each side, right? So 7 is the top one, so that's B. So sorry, the top right one. 8 does nothing, so let's note that. 9 does nothing. 10, top left. Top left is called F, so 10 is F. And 11, that's the top middle, that's called A. So right now we have identified the pins A, B, C, D, E, F, G, and the punctuation. Perfect. Now we can turn on each of the LEDs we want when we want. That's our main goal. Now we need to look at the ports 6, 8, and 9. And I am confident the reason they are not working is because they are enabling the other 3 digits. So let's move this one over to 9. How about that? You can see it's moved from this point to this point, meaning we are enabling digit number 3. So 9 is digit number 2. 1, 2. Let's try 8. That's digit number 3. And the last one was port number 6. That's down here. And surprise, surprise, that's digit number 4. Now we have identified all the pins on my 7-segment 4-digit display, and we are now ready to hook it up. But before we hook it up to be used by the Arduino, I need to add resistors. And I'm going to add resistors to these 4 ports right here. So disconnecting my Arduino, the power, these wires. All I got now is my resistors and my board. So the first resistor is going in port 12. So I'm just going to take the small one if I can and identify port number 12. That's right there. So it goes from 12 to over here. Next one we want is, let's take the high from high to low, so that's 9. So we have 12, 11, 10, 9. That's this one. So I'm just going to leave that in. I'll read the number, so it's 15 right here. So I'm going to take a small resistor into 15 and try to pull it out to a port on the right or row. There we go. And of course I'm using 220 ohm resistors as usual when working with these small LEDs. Next one is port number 8. Also going out, and I'm just making sure I'm not pulling these out to the same row. That would be silly. So you can just see the port number 8 goes out to row number 10, and this one goes out to row number 9. So that's fine. Last one we need is number 6. It's down below. There we go. And now we have the resistors. We are ready. This one is ready to use. So how are we going to connect all of these and these up to the Arduino? Well, we get that information from the code. We're going to do it old-fashioned. So we're going to connect all of these wires to all of the ports on the Arduino. But before we do that, we need to see the software. Now back on the software side, I have identified a page on the Arduino website. It's called 7-segment library. And you can see it's even in short here. 7seg is short for 7-segment library. There's a lot of stuff. What we need is this link right here. When we click the link, we go to this website. This is the GitHub website for this library. All we have to do here is up top right here, we click download zip. So we hit download and we get it there, and you can see it says 2 in parentheses. That's because I have several copies already. Let's go back to the Arduino page after we have downloaded, and let's scroll down a bit and see what's going on. There's something about the hardware, there's something about rows, and here we go, the software. Well, that's the part that interests us. So in order to, let's close that. Use the software, we need to know a few things, but luckily they included a very short example. This one just says how to include the library, how to prepare the library, and how to define which pins are connected to what, and how to actually use the library. And this one is showing you how to define a number, or even you can see moving the punctuation if you want to. So let's head into the Arduino software development, or the IDE. Yeah, here we go. The first thing we want to do after downloading the library is including the library into our software. So I'm going to click Sketch, Include Library, Add Zip Library. Then I'm going to browse to where I downloaded it. It's in Downloads. It's not going. There we go. And you can see I have several of the same. I'm going to click the one I just downloaded. Click OK, and it says already exists. Okay, that's fine. That's because I pre-installed it. If you haven't pre-installed it, it will just install, and that will be it. So now that we have the library, we can click File, we can click Examples, and then all the way at the bottom we got something called 7seg master. It has 2 files inside. It's one called 7seg counter and one called test whole display. Let's open the test display. It's a long file. It has a lot of text. We're just going to remove the text for now. You can read it later if you want. But what we're left with is this code. This code is very informative. It tells us exactly what we need to know to complete our small project. First of all, we include the library as usual. Otherwise we can't use it. Then we instantiate it. We give it a name basically, so we can use it in our code. So we name the library. Then we define how many digits are on our display. Well, we have 4 digits. We define the digit pins. Well, those were the one we had called D1, D2, D3 and D4. Then we need to define our letter pins. those here. You can see A, B, C, D, E, F, G, and period. That's it. This line you should never change. It basically enables the library and runs the library with these settings up here. And this one sets the brightness. That's something in the text here it says something about when you're recording on video it might flicker, etc. For now I'm just going to delete the text and leave it as is on 10. Then we have the main loop. We have a decimal place, it says 0. We're just going to leave it at that. It means we're going to do punctuation on all numbers. We're going to tell the library with this name, remember we named it up here, and we're going to give it the command set number 8888 and all the decimal places 0. Blah blah blah, more text, there's some reference, we're going to ignore it for now, and then it's going to refresh the display. So I'm going to connect my Arduino right away. You heard the pling. And then I'm going to check that it's connected correctly. Arduino Uno. It's the correct port. And then I'm just going to upload it right away. There we go, it's done. I'm going to disconnect my Arduino. There we go, it's offline again. But now I have this code inside my Arduino. Now the only thing we need to pay attention to now is these 4 numbers and these. So let's go through them one by one. Digit pin number 2 goes to digit 1. Digit pin number 3, that's the Arduino pin number 3, goes to digit number 2. Arduino pin number 4 goes to digit 3. Arduino number 5 goes to pin number 4. Sorry, digit number 4. Let's hook that up. There we go. So, what the code said was, it said 2, 3, 4, 5. And these are Arduino pins. And they should connect to D1, D2, D3, and D4. That's these pins. Okay, fairly simple. I'm going to try to separate the pins by color on the wires. So, let's see. D12, pin number 12 goes to D1, or is called D1, so number 12 connects to 2. Arduino number 2 goes to pin number 12. And remember we had a resistor on it from just a few moments ago. Remember the resistor, it's very important. Then we have the second one, the Arduino pin number 3 goes to D2. D2 is pin number 9. So, pin number 3, Arduino pin number T goes to D2. So that's the one way over here. Arduino pin number 4 goes to D3. That's the one in 8. So I already made a mistake right here. Don't know if you can see it, but the resistor I connected this orange to is already connected to 8, but 8 is actually D3. But it's a small mistake, but it's a problem if the digits are being shown wrong. So there we go. Now it's connected correctly. Digit number Arduino pin number 5 goes to D4, and D4 equals 6. So 4 and 6, so that's the last resistor down here. There we go. Now we have connected or enabled all 4 digits from the Arduino to my device. So let's look at the code again. Next line we need to check is this one, 6, 7, 8, 9 to 13, so they are in order. Connects to A, B, C in order to G and period for 13. Okay. Back to my Arduino. So 6, 7, 8, 9 all the way up to 13 connects to these in order. So let's type them out in order. Now let's just connect them. So pin number 6 goes to A. That's 11. 11 is right next to this resistor. Pin number 7 goes to B. That's funny enough, 7. So let's use a little longer one because that's far away. 7 is in between there, like that. Just making sure the resistor is not touching the pin. There we go. Then we have Arduino pin number 8. A, B, C. C goes to number 4. So this is number 6, this is number 5, and this is number 4. Arduino pin number 9 must be G. The wire is coming off, so I'm just going to secure it. There we go. D, it goes to number 2. So if that's 4, 3, 2, there we go. Then we have Arduino pin number 10. So if 2 was D, then 10 must be 11 or E. So there we go. 11 must be F, so that goes to number 10. Way up here. 12 must be G, goes to number 5, so that's way down here. And number 13 goes to port number 3. So there we go. That should be it. However, check number 1. Are all the pins used right now? Well, I already identified one error. Up here I can see from this one, that's 12 right here. We got all of them connected. Perfect. Down here we have a problem. This one is not connected. So let's see what's going on. It looks like I accidentally counted one wrong, so I need to move those 3 one over in that direction. So let's just do that. There we go. There we go. Come on. There we go. Now they are all connected correctly, I hope. And I'm just going to bend the wires a bit. And we already uploaded the test program to the Arduino, so we know it should, when I power it, display 888 and punctuation in all. So let's see. There we go. It says 8888 and punctuation. Let's head over to the software and do another test. That's not the software. This is the software. Let's type something else. Let's type 4 random numbers. There we go. 7651. Let's change this decimal to 2. Upload. And you can see it's uploading. Let's switch back. It turned off. 6561. That's the same. The decimal is not. It's working. Now we have a new test. Everything seems to be working correctly. With the library we also got an example of use. So if we go into examples again, way at the bottom, sev.seg master, there's something called sev.seg counter. Let's click it. Let's close this test. Full screen. Remove all the comment. There we go. And we have this code. Basically the same setup. I'm just checking 4 segments. The main digits are 2, 3, 4, 5, correct. And my letters are connected from 6 to 13. Yes, including punctuation. Yes. So, its brightness is 90. Yeah, whatever. We're not going to mess around with that. We're just going to leave it. Notice before it was on 10 with the number test. Now it's 90. Let's see if there's any difference. I really doubt it. But basically this is just a timer, and it updates the timer. You can see this in seconds, and updates the display. Okay. So basically what this should be doing, it should be counting from 1 to 1000. No, 10,000. You can see it should be reset after 10,000. But it's very slow. You can see it's about 1 second. So let's reduce the time so it's going to count really fast. Upload. Switch. So let's see. There we go. And it's counting fast, but there's a problem. Can anyone identify the problem? There's something in reverse. Can you see what's in reverse? Well, okay, first of all, this number counts very, very fast. That's okay. This number counts, well, if we are going to give them in an order by speed, so this is the fastest, this is the second most fast, this is the third most, and this is the last one. So, these two are reversed. How do we fix that? Well, really simple. The problems are these two wires up here, because from our paper, we remember digits 2 and 3 are on 8 and 9. 8 and 9 are up here. The resistors go out here. So what must have happened is we have reversed those by accident. So if I disconnect one and disconnect the other and plug that in and reconnect this one. There we go. Now you can see it's correct. This is very fast. This is second, third and fourth. Now it's working correctly, and the punctuation is also correctly. So apparently it's a way to identify a potential problem is simply you have connected the wires wrong. Now, how simple was that? It took some time, but the biggest problem people usually have using these displays are identifying the pins and hooking them up to the Arduino. Of course, you can use something in between this and the Arduino to make it even more simple, but we'll look at that in another video. Well, that was not extremely complicated. It was a bit complicated, but it wasn't the software that made it complicated. It was the hardware. It was all these legs. But of course, by taking it slow, step by step, we were able to identify all the pins, and you can see it's still counting. It's running great, and there's no flicker. It's great on video, and that has to do with that brightness setting, remember? So we identified the pins, we tested the device, and we are now running a program on the device and displaying the numbers. That's what we wanted. We had an unknown device with 7 segment displays along it, and we made it work. That was our goal. Done. So, I haven't made any plans for the next video, but we'll see what I'll come up with. Thanks for watching. Comment, rate, subscribe, and if you have any suggestions, leave them in the comment sections as well. See you next time.